In this lesson, we are going to learn about the effects of forces on the structure of a bridge. A group of animals want to cross a river. Do you think the elephant can cross the plank safely? Build a bridge using books and rulers. What are the factors that determine the strength of the bridge? Why is putting the ruler across the two stacks of books that are far apart not as good as putting the ruler across the two stacks of books that are closer? When an object is forced to bend, the top region of the object is under compression, while the bottom region is under tension. A bridge consists of a beam, called the bridge deck, supported at the ends. Bridge decks must be made of materials which can withstand both compression and tension. They must also be fire-resistant and water-resistant. Therefore, the choice of building materials used for the construction of a bridge is very important. Let's look at properties of the following materials. Stone and brick are strong in compression but weak in tension. Cement mixed with sand and water becomes a thick paste called mortar, which is used to hold bricks or stones together. Concrete is made by mixing cement, sand, and gravel with water. If allowed to dry in mold, any shape can be obtained and it sets as a hard white stone. Concrete weathers well and is strong in compression but weak in tension, owing to the large number of small cracks it contains. As a result, it is brittle and unsuitable when large tensile strength is required. In reinforced concrete, the strength of concrete in tension is improved by inserting wires or rods of steel through the wet concrete. As the concrete dries, it sticks to the steel, giving a combination which is strong in both compression and tension. Mild steel is strong in both tension and compression. It is cheap but heavy and it rusts. To counter rusting, it is painted or tin-plated. Stainless steel is more expensive and difficult to work than mild steel, but it is much stronger and harder and very resistant to corrosion. Knowing the properties of the different type of building materials, suitable materials can then be chosen for the construction of a bridge. Nowadays, most bridges are made of reinforced concrete that is strong in both compression and tension. You've seen a bridge, and it's almost as likely that you've traveled over one. If you've ever laid a plank or log down over a stream to keep from getting wet, you've even constructed a bridge. Bridges are truly important, a natural part of everyday life. A bridge provides passage over some sort of obstacle, a river, a valley, a road, a set of railroad tracks, and even a hole. Bridges are everywhere. There are wooden bridges, overhead bridges, iron bridges, suspension bridges, and cable bridges. The type of bridge built depends on the volume of the vehicles using it, length or span of the bridge, and also the choice of building materials. There are 4 types of bridge structure: How can we determine which types of bridge structure suits our plan to build a bridge? The type of bridge used is obstacle. The main feature that controls the bridge type is the size of the obstacle. How far is it from one side to the other? This is a major factor in determining what type of bridge is used. The load on a beam bridge is supported by piers. The further apart the piers, the weaker the beam bridge. Hence, a beam bridge cannot be very long. When a lot of traffic is on the bridge will bend. The upper part of the bridge undergoes compression and the lower part of the bridge undergoes tension. If overloading occurs, the bridge will break, starting with a tear from the lower part of the bridge and spreading to the upper part. When load is put on the arch-type bridge, the weight of the load exerts great forces to open up the arch. As the arch is already under compression, it takes a very great force to open it up. Hence, the arch bridge can withstand tremendous load. In a cantilever bridge, the steel bars are constantly under compression or tension. In a suspension bridge, the roadway or the deck is suspended by hangers, which are attached to the steel cables. The steel cables are draped over the towers and anchored onto the concrete block known as the anchorage. As the steel cables suspend the roadway, the entire weight of the bridge and its load is resting on the two towers by way of the steel cables.
Design and build a suspension bridge. Materials needed: ice cream sticks, string, loads, glue, rubber bands or small clamps. Use the materials provided to design and build a suspension bridge that can hold loads from 2 kilograms to 5 kilograms. Put the bridge in between the two tables. Use your creativity and knowledge based on what you have learnt to build a sturdy bridge. Test the strength of the bridge by putting loads on it. Answer the following question based on your observation. What are the factors that determine the strength of your bridge?
To design and build a bridge, engineers must consider many things, like the distance to be spanned and the types of materials available, before determining the size, shape, and overall look of a bridge.